Good morning, ladies and gentlemen. We have one more very important property of parallelograms to discuss this morning. So let's look at parallelogram ABCD and sketch the diagonal AC. If we look at the diagonal AC and the angle 1 and angle 2, those angles are congruent because of the alternate interior angle property of segment AD being parallel to segment BC. And as we've done in class, to help us see that, we could extend these lines, if you will. Those are my parallel lines, and therefore AD certainly is this transversal, and I have these alternate interior angles there that are congruent because of the fact that AD is parallel to BC. In like manner, to keep our diagram from becoming too busy, I'm going to look at the parallelogram again and sketch the diagonal BD. And again we see, in like manner, that angle 3 is congruent to angle 4, and that's also because of alternate interior angles of segment AD being parallel to segment BC. And as I did before, to help us see that, help us realize that, I could extend these lines and make them where you can really see that this transversal is cutting through those two parallel lines, and you can really see that angle 3 is congruent to angle 4. So we're going to use that information, the fact that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. What I'm going to do is put both of those diagonals together on one slide, as I've done here. And my claim here, I want triangle AED to be congruent to triangle CED. Let's write my congruent symbol at head better, please. Let's write this E guy a little bit better. We will. And E is the intersection point of the diagonals AC and BD. It's where the two diagonals intersect of this parallelogram. And what I want to do is going to be very useful if I can actually prove this claim here that triangle AED is congruent to triangle CEB. So I've got a little typo here. Let's change my typo. Let's make the typo correct. This is going to be CEB. It's nice when I have typos. That way I can go through it and you can kind of double check me for little itty bitty errors like that. So this is what I want to do. I want to prove that triangle AED is congruent to triangle CEB. Let's see if we can get that accomplished. Well, we know that angle 1 is congruent to angle 2. Alternate interior angle property of lines AD being parallel to line BC. We also know that AD is congruent to BC, and we know that, we proved that in a prior lesson. That's a property of parallelograms. And if you notice, one thing that you will notice is the properties follow one after the other. If you prove a property, then you can use it to prove another property, as we are doing here. So I have AD congruent to BC, and that's because of a property that I have proven prior about parallelograms. Opposite sides are congruent. I also see that angle 3 is congruent to angle 4, and that's because of alternate interior angles of segment AD being parallel to segment BC. Oh, and look what I have. Now I have triangle AED is indeed congruent to triangle CEB. Why? Because of angle, side, angle. I do have two corresponding angles. I have 1 and 2 corresponding. I have CB and AD corresponding congruent, and I have 3 and 4 corresponding congruent. So this triangle AD is congruent to triangle CB. That's huge. That's a very nice fact. Because now look what I can make. I can make the statement here, right from this congruent statement, that segment AE is indeed parallel to segment CE, and that segment DE is congruent to segment BE. That's because of corresponding parts of congruent triangles are congruent. This is one of the very first things that we talked about when we talked about congruent triangles. We had all these corresponding parts. So this is a very useful information. What does that tell me? If AE is congruent to CE and if BE is congruent to DE. What that tells me, ladies and gentlemen, boys and girls, that if ABCD is a parallelogram, what do I know? Then I know that the diagonals bisect each other. That is good stuff right there. That, ladies and gentlemen, is good stuff. That should make us really happy. That's going to make our whole life easier. It's certainly going to help us on a couple of the problems that are assigned for tomorrow. So let's just do some examples. If I look at this, here I have created 2 segments. And what I've done with those 2 segments is I have tried to put them in a manner that they bisect each other. And I think I'm pretty close. I took my ruler and I estimated, but that's pretty darn close. Look what I'm going to do now. What I'm going to do now, I hope I get this done without messing it up. I'm going to connect the endpoints of those segments. I knew that was going to happen. Look at this. Oh, fiddlesticks. Look at that dude right there. What does that black quadrilateral look like? You betcha. That looks like a parallelogram. We're going to talk about this as soon as we get back to class here, because what we did is we used the converse of that theorem, was that if I have 2 segments that intersect each other, then the quadrilateral that connects the endpoints of those segments is indeed a parallelogram. This we will look at in more depth and more precisely. We may use some wiki sticks to prove this fact. This is a nice fact to prove with wiki sticks. So let's go to the very last slide of this presentation and just do some algebra problems. So I have this parallelogram, given parallelogram. It's got to be a parallelogram for this to work. So I have parallelogram. We're going to use our parallelogram notation for A, B, C, D. And I have some lengths. I have that AE is equal to 4x plus 2, and EC is equal to 3x plus 4. And just to review some algebra, I want to find out what x is, and then find the actual length of AE and EC. So I make those statements equal because, why? Because the diagonals bisect each other. E is the midpoint. And I know, and I could preface this particular algebraic statement, which it probably would be a good idea to do that AE is equal to EC. That is because of a property of parallelograms. Diagonals bisect each other. E is a midpoint. So now I'm going to set 4x plus 2 is equal to 3x plus 4, and I solved that very simple algebraic equation. Subtract 2, subtract 3x, x is equal to 2. Therefore, I'm going to use the fact that x is equal to 2, and I'm going to find the value, the length of AE, which is going to be 4 times 2 plus 2, which is 10. And I'm going to find the length of CE, which is going to be 3 times 2 plus 4. And they should indeed equal each other. So let's find out what the value of y is now and find DE and EB. And again, what I'd like to do is start off making the statement. I'll make the statement in red that DE is indeed equal to, what was that rascal? EB. And these algebraic expressions were given in the problem, and now I have this algebraic equation that I'm going to solve very easily. And I picked out some easy ones to solve. You can certainly do this. Subtract 2y, add 7 to both sides. Y is equal to 18. And this statement right here is because of the property of parallelograms, and therefore I have DE is equal to 3 times 18 minus 7, which is 47, and BE 2 times 18 plus 11, which is equal to 47. So that's just one more property about parallelograms. I think we have now covered all of the properties of parallelograms, and you can use this to help you with the assignment that is due when I see you next. You guys have a wonderful day.